In this video, I'm going to explain one question that was given in the last assignment, and through that question, I'd like to explain the thought process that you need to follow while solving such problem sums. So this this thought process actually is not only specific to questions based on momentum, conservation of momentum actually, but this thought process can be applied to almost any problem in physics. You just need to modify it. So let's start. So the question was about two clay balls. So here, let me get two clay balls. So these are atta balls, but that doesn't matter. So this is the first clay ball was a 1 kg clay ball. I'll just label that here, 1 kilogram, and the second one was a 2 kg clay ball. So we have the mass of the two balls, and both the clay balls were moving. So the first one was moving at 4 meters per second in this direction. So let me write that too. 4 and this one was moving in this direction at 3 meters per second. So we know that this ball, which is moving at 4 meters per second, is moving faster than this ball, which is moving at 3 meters per second, and therefore after some time this ball will hit this ball. So first of all, let us analyze this situation, which is before the collision. So what you need to do is, in questions that involve collisions and you have to apply conservation of momentum, so first of all, look at the situation before the collision. So this is the situation before the collision. What is the total momentum before the collision? Well, the law of conservation of momentum tells us that the total momentum before the collision is equal to the total momentum after the collision. So first let us find the total momentum before the collision. So the total momentum before the collision would be the momentum of this ball plus the momentum of this ball. So the momentum of this ball is simply its mass, which is 1 kg, into its velocity, which is 4. Obviously kg meter per second. And then the momentum of this ball would be its mass times its velocity, and we have the units, and we simply add the two. So this here is the total momentum of this system before the collision. So what I can do is I can simply multiply these two. So 1 into 4 is 4, plus 2 into 3 is 6. And so we have this thing with the units, and if I solve this further, I get 10 kg meter per second. So that was the situation before the collision. So before the collision, the total momentum is 10 kg meter per second. So by the law of conservation of momentum, we know that after the collision, whatsoever happens during the collision, after the collision, the total momentum of the system should be 10 kg meter per second, because total momentum is conserved in any collision. So now let us collide the two balls and let us look at the collision after. Let us look at the total momentum after the collision. So after the collision, we just saw that this ball here, which was here, it moved and it collided with the other ball, the heavy ball, and because the two balls were made of atta, or in the original question they were made of clay, they got stuck together and they formed a larger ball like this. Okay, obviously because this is made up of two balls, so the first one was 1 kg ball and the second one was a 2 kg ball. Therefore the total mass would be actually this mass plus that mass. So the total mass in this case would be 1 plus 2, which equals 3 kg. So after the collision, because the two collided and stuck together, the ball became heavier, and the two masses, we need to add the mass of the two smaller balls, the 1 kg and 2 kg ball, to get the mass of the final larger ball, which is 3 kgs. Obviously, because there was a collision, the velocity of the final ball might be different from the initial velocities of the two individual balls, and therefore let us remove the original values. So here I have the final situation after the collision, and the final situation is somewhat like this. So I have a bigger ball that is composed of the smaller balls, and that bigger ball weighs 3 kgs, and it is moving at some velocity which I don't know, or which I have to find out. So all that I know is that the final momentum, or the momentum of this system, which only has one ball in this case, should be 10 kg meter per second. So let us first of all find what is the momentum of this ball. So the momentum of this ball must be its mass times its velocity. So let's say its velocity is, instead of writing the question mark, I say it's v. Let's say it's v meters per second. So its momentum would be its mass times its velocity, which is v, and the whole thing is kgs meter per second. And this, by the law of conservation of momentum, should be equal to this. So I can just write that here, 10 kg meter per second. So now finally I have got an equation where I have only one variable, which is v, and I can just solve this equation. Just to simplify, I can write the equation as this, and now I can remove the brackets because we don't really need them here. So now I simply have 10 equals 3 into v. I can shift the 3 to get on this side to get 10 upon 3. So essentially I'm dividing both sides by 3, and here I am left with v. I can obviously switch the equation this way, and I get v equals 10 by 3, which should be around 3.3 and 3 repeats meters per second. So that is the answer, and this is the actual use of law of conservation of momentum. So I can use the law of conservation of momentum to figure out the velocity of an object after a collision. So it doesn't matter if the collision is something that involves fusion of the two objects, or two objects getting stuck together, maybe like two cars getting stuck together in an accident, or even if the collision is an elastic collision, or a collision in which the two objects bounce apart. Even then I can use the law of conservation of momentum to find one of the velocities if I know the other after the collision or even before the collision. So only one unknown should be there. So this is how we use it in this question.